So with this, we will be looking into the final distribution, which is a Weinbull distribution. So in many cases, the event rate does not remain constant over time. So if the period over which it changes is much longer than the typical intervals between events, there is no problem. You suggest you just subdivide the analysis into segments where rates are relatively constant as mentioned before. So if, however, the event rate changes over the time of the interval, the exponential or Poisson distributions are no longer useful. This is likely to be the case in mechanical failures. The risk of failure increases as time goes by. So the Weinbull distribution is an extension of the exponential distribution that we have just seen, in which the event rate is allowed to change as specified by a shape parameter beta. If beta greater than 1, the probability of an event increases over time. If beta less than 1, the probability decreases, because the Weinbull distribution is used with the time to failure analysis instead of event rate. The second parameter is expressed in terms of characteristic life rather than in terms of the rate of events per interval. So the symbol used in is Greek letter eta. It's also called the scale parameter. So the Weinbull distribution is a probability distribution used to model a time to failure of a system or component. It's widely used in reliability engineering to analyze and predict the lifetime of products such as electronics, devices, machines, and vehicles. The Weinbull distribution is characterized by two parameters. One is the shape parameter K and the scale parameter lambda. The shape parameter determines the shape of the distribution curve, while the scale parameter determines the location of the curve along the x-axis. So now the Weinbull distribution has several applications in data science, including reliability engineering. The Weinbull distribution is commonly used to model the lifetime of products and to analyze the reliability of systems. Engineers use Weinbull analysis to determine the probability of failure of a product or component at a specific point in time and to optimize maintenance schedules. Then we have a survival analysis. The Weinbull distribution is often used in medical research to analyze survival data such as the time to death or time to failure of a medical treatment. Then we have the quality control. Quality control, the Weinbull distribution is used in quality control to model the distribution of defects in a manufacturing process and to identify patterns in the defects. And the fourth one is a financial modeling. The Weinbull distribution can be used to model the distribution of returns in financial markets and to estimate the risk associated with different investment strategies. So an example of using Weinbull distribution in data science is in the analysis of the lifetime of components, or mechanical components. Suppose a company manufactures a certain types of mechanical component and it wants to estimate the lifetime of the component and optimize its maintenance schedule. The company collects the data on time to failure of the data components and fits a Weinbull distribution to the data. By analyzing the Weinbull distribution, the company can estimate the probability of failure of the component at a specific point in time and date determine the optimal time for maintenance. So this can help the company reduce downtime and improve the reliability of its products. So similar kind of project we have worked on in Volvo. So predictive maintenance application.